Next is cross-price elasticity, which is one product compared to another product, right? So it's not own product, it's cross, right? So remember the word cross. Here, the expression shows the elasticity for the quantity of X in terms of demand given the price of Y. So here we're mixing X, which is our product, and Y, which is, say, a substitute or complement. When we compute the elasticity, if it's greater than 0, then the two of them are substitutes. Let's just pause a moment to look at how this works. If the price of Y goes down, then the volume of Y will go up. And therefore, if our product goes down, then we're substitutes, right? Because they can buy their product versus ours. The opposite is true too. If the price of Y goes up, the demand will drop for Y. And then since we're substitutes, people run from the Y product to the R product, X. So we're seeing this, if it's a positive number of elasticity, then it is a substitute. If it's a negative, then it's a complement. Let's try that out as well. Let's say an example of pretzels and beer. Those are complementary items. If the bar raises the price of beer, then people will buy less beer, so Q of beer goes down. And because they buy less beer, they buy less pretzels, so sales of pretzels also goes down. So in this case, if the elasticity is less than 0, namely a negative number, then we are not substitutes, we are complements, right? So that's the relationship of one product and its pricing and how it affects the demand of your product. Let's try this out. So here's our example. We've estimated the cross-price elasticity of negative 0.18. And if the price of food is projected to increase by 10%, what would the demand for clothing, how would the demand for clothing change? All right, so here we have the problem stated on the left, and then here's the formula of cross-price elasticity for reference. And what do we know? So we know the following, that the cross-price elasticity is negative 0.18 equals, and then the change in quantity is our variable. Just be sure, let's call it change in quantity, divided by the price change, which we're given here is 10%. It's a plus 10%. So 0.1. So we solve this. So the change in Q is equal to negative 0.18 times 0.1. And so in this case, the answer is negative 0.018, right? So that's the answer to this. All right, let's use the formula that we were given, which is right here for a reference. Elasticity equals the change in Q divided by change in P, and then we're given this data. So let's put the data in and see what happens. We're given that the cross-price elasticity between clothing and food is negative 0.18. We want to determine the change in quantity, and that's divided by the change in price, which we are given. It's going to increase by positive 10%, right? So now we could say, solve it. Change in Q equals negative 0.18 divided by 0.1. And that result is 1.8. What does this mean? That means if the price of food increases by 10%, it's going to change our demand for clothing by negative, it's going to go down, by negative 1.8%. So that's how we could use cross-price elasticity. There's another use of cross-price elasticity. What happens if you're a firm that has multiple products? You want to know what is the impact of changing of the price on one product on the other product. And here's an example of how that is derived. So assuming that we have overall change in revenue from two items, two goods, then the delta R, which is the change in revenue, equals the impact of the change on the first good plus the impact of the change on the second good. And as a mathematical formula, it's right here. Delta R equals the revenue from X, which is that first product, and that's multiplied times 1 plus the price elasticity, plus the revenue from the second product, called Y, times the cross price elasticity, and that expression multiplied times the change in price. All right, so we'll be using this in an example on the very next slide. Let's use this newfound tool, right, to look at total revenues and the relationship that we get with cross price elasticity. Suppose a restaurant sells $4,000 a week from hamburgers and $2,000 a week in soda. And we're given the own price elasticity of -1.5 for burgers and the cross price elasticity between sodas and hamburgers of -4.0. What would happen to the firm's total revenue if it reduced the price of hamburgers by 1%? Right? So go back to Excel and we'll use this function. On the left, you see the problem, and on the right, you see the expression that we have just looked at previously. All right, so now we're ready to solve this problem because we have the expression above, the data on the left, and we put them together. So change in revenue equals, and we'll do this nice and slowly. We have the revenue from hamburgers, 4,000, times 1 plus the elasticity, the own price elasticity of -1.5. And then to that, we add 2,000 for the soda times the elasticity, cross price elasticity of -4. And we have that expression multiplied times the change in the price of hamburgers, which is a reduction of 1%. So it's minus 0.01. So now we can solve it. So equals 4,000. I'll just keep the parens, 4,000 times, that's a -0.5, plus 2,000 times a -4 multiplied times a -0.01. Answer is $100. So what would happen is if we reduce the price of a hamburger by 1%, the overall change in the revenues for the restaurant is going to be a positive $100, right? A lot of work to get $100, but it's better than nothing.